Okay, so why are we going through the simplification? Well, with your circuits, when you have Verilog and it starts to evaluate all the circuits that you put into it, those generally map to some type of Boolean algebra, and then it needs to figure out how to simplify that in order to optimize your circuit. Yeah. Fewer gates is better. Hopefully we see that. So we want to simplify the smallest number of literals. When we're talking about literals, we're talking about the number of inputs. So, for example, on the top one, you have A, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, it's a lot of literals. But a lot of inputs. But if you simplify it just enough, you can get down to what looks like 5 literals.
Yeah.
Yeah. All right. So complementing functions, right, you can always use De Morgan's law to find the complement of a function. Remember, if f is x naught y z naught or x y naught z naught, you can always put a giant bar above both of them and then use De Morgan's law to simplify it out. So the other example, you need to do the complement of g. What's the complement of g? Not G. Nice. Liked it. Good job. But I already gave you that. Good try. Good try. Good try.
So you put a knot over everything?
All right, so we're going to put a knot over everything.
It's an E. I mean, E and C are very different things.
I believe you.
Okay. I need paper.
Do we need to distribute the D before we dot everything?
That is going to be a wise decision.
Yeah.
They just change the signs, right? D.
A or
Change all the
D.
signs
Yep.
and then knot them again. All
A
right.
or D. Whoa. Hi, James in Charleston office.
Street just at the end of the
Yeah. Oh, where are we going?
Ice cream shop.
Oh, sweet. Just so you know, there's an ice cream shop downtown.
There's a lot of ice cream shops.
So we all going for ice cream?
Oh, hold on a second. Yeah, we're all going for ice cream?
There'd be two knots, right? Over
Two
A.
knots
Yeah.
above A. So then-
Plus not B.
But and.
Oh, this is just annoying.
Yeah.
Yep. Almost like me.
Wow.
Are we going to show this to the online students?
No.
Nope. That was fun.
The D doesn't the D have two?
D needs 2.
Huh?
Yeah, D does me too.
Because of the signs. So then you get A plus D.
I'm done.
Oh.
So you,
I feel
You
like
wouldn't
that's
change
not
back
really
like the D to just like regular D?
You can.
Okay.
I wouldn't give full credit for that.
Yeah, I would give like maybe partial. Maybe partial.
He's honest.
Dang.
It's not fully simplified.
You guys know he's going to do that to you.
Yeah, I know. That's what he's thinking, like a mental note.
Mental note. For Matt, he has to simplify it all the way or minus 20. Got it.
Minus 20.
It's always minus 20.
Minus 20 on the whole test.
Yeah.
Whether the problem's worth 5 or 10 points.
Minus 20. Always minus
It's a
20.
quiz that's
I'll
only
make
out
you
of
proud,
10
Becky.
points, minus 20.
Minus 20. If you just didn't turn it in, you would have done better.
Yeah, maybe he'll forget it in my name's mistake. So.
Yeah, well, that is true.
You'll be looking nice.
Of course, it's hard to forget when you're wearing that shirt.
Oh.
My name is David today. I promise.
All right, canonical forms. All right, why do we have canonical forms? Why are we going to midterms, max terms? Why are we going to go into all these crazy representations? Well, before we can have Verilog do any optimizations, we have to simplify or change your circuits into something that Verilog can manipulate. That's what this is going to all be about, is changing into something that can be manipulated by a computer program. And then next class we'll actually talk about optimizations. Hey. All right, so canonical form, it's used to specify Boolean functions that allows comparisons for equality. It has correspondence to truth tables. Basically, it makes using the truth table easier if you put it in this form. It has two common usage. I'm going to put some extra syllables in there. Sum of midterms or product of max terms. So you're either going to have a sum of somethings or a product of somethings. All right, midterms are and terms. Every variable represents true or complemented form, so you either have x or not x. For example, if you have x or y, there's only 4 possible combinations of the two. X, y, x and y, x and y naught, x naught and y, or x naught and y naught. 4 minterms for 2 variables. All right? Notice that x by itself is not an acceptable minterm. It has to be x and something else. Okay? So now your minterms are based upon the number of variables that you have. So if those are minterms, what's going to be the max terms? Which are, instead of anding, we're going to oring. Whoa. Whoa! Okay. Max terms are or. Again, you have the variable and the complement. So for 2, you only have 4 possibilities. Again, x cannot be by itself. It has to be x or y naught, x naught or y, x naught or y naught. How many combinations would there be for 3 variables? 8. And then for 4 variables? 16. Okay, we're doing great. Thanks. You're doing great. Look, after about 4, we usually...
No, just keep going.
Well, that's the computer's job, right?
Yeah.
Yeah, we don't care about that.
Maybe I want to.
What was that?
I said maybe I want to.
No, okay.
Good luck.
I mean,
All right, now, this is where things are going to get a little weird. We're going to assign an index to each minterm and max term. We are just assigning this number. There is the intuition of why we assign these numbers will make sense later. Right now, we're assigning these numbers. I'm going to write them over here. 0, x naught, y naught, and you got x or y. Hey, what's the relationship between those two?
Complement.
You see that? They're the complement.
Oh,
So there is a relation between the indexes.
yeah.
So that's good for your midterms and your max terms. For those of you listening at home and can't see what I'm doing on the board, I'm literally just writing that on the board. That way I can hide it while y'all try and figure out what's going on. Okay. All right, so standard order. So these are specifically designed, namely minterms and max terms, to be designated with the subscript. The subscript is a number corresponding to a binary pattern. All variables will be present in midterm or max terms and will be listed in the same order, usually alphabetically. For example, ABC, if you were going to list the max terms, that would come first. So that's what they just said doesn't make sense. Here are some example max terms. But what they're saying here is each individual one, you have to start with A, then B, then C. So you don't do B or A or C, or you flip the order. You always go from logical alphabetical order. It has to be in that order. By constraining all these ways, good things are going to happen. Well, I'll say better things are going to happen tomorrow. Or next class, actually. When do we meet on Monday? We don't have Monday off, do we?
No.
Okay.
Not that I'm aware of.
We can though if you cancel class.
Thanks, Carla.
Or I mean, if it miraculously snows again.
Yeah. Which apparently it's supposed to.
What?
You want it to snow again?
it's going to snow?
Wait, is it actually supposed to snow?
According to the Farmer's Almanac, which actually predicted a snowstorm recently, they predicted another one in February.
It's like
End
the
of
first
March.
through like
Hopefully
the
on a
6th.
Monday or Wednesday.
Yeah, somewhere around there in the beginning. Yeah.
No. I fly out that day. Gotta fly back in.
No, you're just not covered.
Watching you miss all the snow.
I know.
Did you miss the snow last time?
Yeah. I was in
Okay.
South Dakota.
Well, then that makes
Came back
sense.
and then-
Oh, well, you have snow in South Dakota,
Yeah,
right?
so it didn't matter.
It doesn't matter.
And then down here, no one knew what to do with it, so I was like,
Yeah.
Yeah, well, that's why I like it
They
there
tried
because we just closed. We're like,
Yeah, they
oh, it
put
snowed.
sand
Oh,
over it.
yeah, that was yeah.
I
That was so
I couldn't even fly
stupid.
into Charleston Airport
Yeah,
because it was closed. So.
That's why I like it when it snows here. We just give up.
Yeah.
Yeah.
we literally like
just
bunker
give up.
down and wait for it to melt.
Yeah, we're like, we don't know
It'll
what to
melt
do.
in a few days. It's okay.
Well, usually it melts in a day, but not this time.
I literally had in middle school a class, like the day was canceled for a warning of a 1/4 inch of snow.
Yeah.
Yes, but we all
We
Okay.
had a warning.
You already
it's
see how
going
people
to,
drive
like,
in good
flurry,
weather around
and that
here.
was it.
All right, so back to the subject.
Back to
Great.
the future.
So for midterms, which ones were the midterms?
The ants.
The AMs, right.
Ants.
One means not complemented. Ooh. 0 means complemented. Wow, that's kind of confusing. And 0 is the other, and max terms the other way around. All right, that's confusing. So we're gonna move on. Let's not.
Let's just not and say we
Okay.
didn't.
So here's an easier way to think of it. So min-term 0 is called little m0 and is x naught, y naught, z naught if it has 3 variables. Hey, look, 0, x naught, y naught, and then if there's a third one, be z naught, right? That's how it starts. Because if we have a third variable, you're just adding z naught, so forth and so on. The max term for 0 starts with the OR of all the uncomplemented things. That's what we're talking about back here. Because 0 means not complemented. Okay, min-term 6. All right. Let's what would min-term? Actually, let's do it this way.
That's a lot of variables.
Let me go back to the board. Let me write these indexes differently. I'm going to write them in binary.
Oh no.
Think about, wait for it.
Oh, so it's the.
Yeah,
Oh.
whoa! The bit tells you if it's knotted, if it's complemented or not.
Oh.
0 means it's complemented in the min-term, but then not complemented in the max term. 1 means it's not complemented here, but complemented there. 0, complemented, not complemented. 1, not complemented, complemented. Okay, so what's 6 in binary? Well, that's 4 plus, not 4, well, 4 plus 2 plus nothing else. Okay? So x, y, and z. So what would be the min-term? Start.
X, Y, not
Just the
Z.
So the min-term, which be x and y and z. What would be the max term?
Oh. Would be
X not A.
not X.
Oh,
X
x
not
not
or. Y not
or.
Z.
Okay. All right.
Right?
Yeah.
I got lost. Not X or not.
All right. Let's
Z.
start back over here.
We're going to min-term
Not
6.
X.
We're looking for.
So the first one's the x, then the y, then the z.
You convert it to binary.
Always convert the number to binary. And if it's a 1, like over here, that means that that number for the midterm is not, all right, we're good. All right, how we doing now?
So when you wrote,
I always look back there and I can't decide if the look is like, all right, this is boring, or what's
is
going
it?
on?
Face.
What?
Just my face.
Well, the problem is I only see part of it because of the computer. So sometimes I only see the eyes. So it's like, I don't know if she's smiling or scowling right now.
It's a
So-
mixture.
It's a mixture.
So the min term is X, Y, Z. I mean, is one is
Well, they're all, min terms and max terms are always going to have X, Y, and Z in it.
Right.
Always.
right, and the max term was 110.
No,
Oh.
6 is 110. So if
He's
it's
saying
110, aka
You
mapping
need
like
to
over.
answer the actual question on the board.
Oh, okay. What is midterm 6? Is that what you're asking?
Yeah.
Yes.
All right. So midterm, which is the anding,
Oh,
would be
gotcha.
x and
No.
y and not z, or z not.
I thought you had written 110 or 110 beside max term 6. That's why I was so confused.
Oh, well, 6 is equal to that. You know, they're both
You're just saying that's the binary number for 6.
correct.
Yes. That's not the answer to the questions on the board.
No, not at all.
No.
Now, I'm worried.
All right, let me go and write the answers.
Yeah, there you go.
So 6 equals 110 base 2. Okay, look, it's nice and diagonal. So 1 means it's not complemented. And then over here it means it is complemented.
Interesting.
You should show that to the online.
All right, online people. This is going to be so professional.
Yes.
Oh, we're going to get Inception. It's going to be even better.
Well, at least they'll be able to see it in multiple spots.
Midterm of 6. 6 is equal to 110. Therefore, that 1 corresponds to regular x, the y, regular y, the 0 to not z. Max term of 6, again, not x, or not y, or z. Oops, there we go.
Ta-da! Got multiple views.
Yep.
They've seen it.
Okay, guys. Just to make sure this is in everyone's mind, you all get to write these.
Oh.
Or you can tell me. Or do you want to tell me?
I'm whistling.
Oh, okay. All right.
So we, the first,
A plus, well, A or B or C or not D.
yeah,
Yeah.
simple enough.
Okay.
So it's A, it's not A, not B, C, D.
Right over the question mark.
Wow.
That sounds great.
Not A, B, C, D.
So we're starting off with knots.
Yeah, because the midterms start with knots.
Not A or not B
C.
or C or something.
All right.
Yeah.
How's everyone doing?
Magic.
Great.
Thank you, Jonah.
You're welcome.
Magic.
It's
She's
magic.
No, she said dying inside.
Dying on these.
You
Oh,
need to
okay.
erase what's on the board now?
Yeah, we can't see what's going on.
Oh, you didn't show
Y'all are
that.
so
Did you not show
complaining.
that
Oh no, they don't get the
too? I didn't get
hint.
anything.
All right, De Morgan's Law.
Poor online students.
They heard what he said.
Oh,
So
that's
we have De Morgan's Law.
It's just
Hopefully y'all can actually see, if you think about it, M2, which is the o-ring, if we have not x or y, and then we complement it, we will get little m2, right? So, if you, the big M sub I is equal to the complement of the little m. The
Aw.
max term is the complement of the midterm. And of course, the midterm is the complement of the max term.
Yay!
Whoa.
Party.
All right. Here is the function for both.
Oh my gosh.
Whoa. All right. So if we're going to do the truth table, we have x and y over here. You have your, what are these again? Minterm.
Midterms.
And then over here you have your max terms.
I keep hearing midterm and I keep thinking of midterm and it just makes me want to cry.
Minimum term.
I got it. But I hear midterm until I look and I'm like, there's an N. I'm glad.
So
there's
why
an
is
N
the
there.
Internal
midterm
term.
or minimum term sub 0 1? Why is it 1? What is it? Yeah, because you have the complement of x and the complement of y. X is 0, 0, so complementing that would be 1 and 1, which is 1.
Oh, yeah.
Yeah.
And then obviously the rest have to be 0 because one of them is going to be 0. So
Right.
if you look at the truth table for the min term, it goes
It's ones and another one's zeros.
right.
Yeah.
And then,
Nothing. Thinking.
thinking? All right.
7.
And then the max terms, hey look, it's the opposite.
Whoa.
Just again showing you that the min term, this is really just proving to you that the min term and the max terms are the complements of each other. They complement one another. All right. Oh, anyone confused? Questions?
No, just look at the max term over there. Okay.
Okay. Let's see. Each min term has one and only one present in the 2 to n terms. That's an interesting place to put the n. All their entries are 0. The max terms has only 1 0 present in the 2 to n terms. All others are 1. It's a maximum of the ones. All right, sure. That's where the names came from. Now that we understand min terms and max terms, we're going to go into a canonical forms. There are 2 canonical forms. You have the sum of min terms and the product of max terms. And it turns out that any Boolean function can be stated as a sum of min terms or a product of max terms. Okay. Sum, for example, find f of 1 equals m sub 1 plus m sub 4 little, or I should say, min 1, min 4, min 7. Well, you just translate that 1 over, which just means the z is not complemented, and you go x naught, y naught, z, or x, and then you go over to 4, which is, we'll do it right here. 1 equals 0, 0, 1, 4 equals 1, 0, 0, and then of course 7 equals 1, 1, 1. You see how that happened? And then since it's a sum of midterms, why they decide to all of a sudden make sums equal to plus, just let it go. So we're going to OR them, not adding them, we're ORing them. And they just called them sums.
That's terrible.
Look, there's no reason why we're stopping after all this. All right, here we go.
Oh my gosh.
Oh, okay, then you can go ahead and write out the truth table if you wanted to. Great. All right, how about this one?
Whoa.
Oh, man.
It hurts my head.
It does? Okay. Anyone else need this truth table? You need a picture of it.
Oh, it's on the video.
Okay. Oh. Thanks. All right. So that doesn't work. A function of A, B, C, D, E is equal to m sub 2 plus m sub 9. Ooh, that 9 looks like a cube.
Lovely numbers.
Hey, that's why we have computers do this, right?
Sure.
Yeah. Okay. Oh yeah, this needs to go over here. This should be professional.
Oh my god. These poor people.
Oh.
Too low.
I don't know if I could watch this video later. I'd get motion
Okay.
sick right then. Just the whole camera's away.
All right.
We'll have to work
M
on it.
sub 2. What's 2 in binary? Wait, how many bits do we have?
5.
5. Great. All right. So what's 2 in binary? 5-bit binary.
0, 0, 1, 0.
All right. So what's M sub 2?
A, not B.
A naught, B naught, C naught, D, E naught. Then we're going to add what? 9. What is 9 in binary? And 5-bit binary.
01001.
Yes.
Just know.
All right. So what's the next one?
A naught B, C naught, D naught, E naught.
Let's see. D dot E. All right. We're gonna go down here.
17 is 10001.
No. Starts with 1.
It's 10001 for
1
17.
0 0 0 1.
Yeah.
Because that is 17 in binary. So then what's the answer?
It's A not B not C not D E.
B naught, C naught, D naught,
E.
E. Is that big enough?
23.
Good, it's getting bigger and bigger. All right, so 20. What's 23 in binary?
101.
16 plus 8 is 24.
Yeah, no, 101.
Oh yeah, you're right.
So it'd be 4, which would be 20.
There we go.
1 1.
So then it'd be plus.
So it's A not B C D E. Is it sad I like working in binary?
Yes.
Binary
what?
and hexadecimal are fun.
They are nice.
The conversions.
All right, everyone got this? Sure. All right.
Better than great.
Now let's do it in max terms.
Oh, great.
Oh yes.
So again, up here, max of 0. Well, then this one's a little nicer because the ones tell you what is complemented. So none of it's complemented. But now it's the product of max terms. So your terms are ORed. Put your parentheses around them, and then you AND them all together. So the next one is 2, which means the y is complemented. 3 means that the y and z are complemented. 5 means that the 4 and 1 or the x and z are complemented. 6 is the 4 and 2, so then the x and the y are complemented. Doing great?
Always.
Hey, here's a giant truth table.
I love those.
Thank you. Thank you, Carla. I do too.
I like the little ones.
All right, let's do it again. Nice and big this time. For the people at home. I know.
Whoa. That's a little,
Excessive?
yeah. Now you're not gonna be able to see the dots.
I think I got overzealous.
I think so too.
M14. Sounds like a military weapon.
The M14.
The
Because it is.
It is a-
It's a gun.
Oh, there. See, it all fits. All right.
Yeah, let's not break that big.
So 3 in binary with 4 bits is what? 0 with 4 bits.
0011.
1, yeah, 1, 1. Which means the first term is?
Not.
A.
No, it's just A.
A, B, not
Or
C not.
A or B or
Or-
C naught
Or
or
D naught.
D naught. Then you add,
No.
so that was the 3.
No.
Thank you. You or.
Yeah. Wait. What?
No.
Why are you
No.
boring?
Add.
You are ending it, but you don't add it.
Wrong symbol.
That's A.
You and it.
1
The
0
next one's
0.
8. Yeah, there you go. 1 0 0 0. So that's what?
Not A. B C D.
Come on. Don't say
Or
BC.
B.
There you go. Otherwise you're going to write it and it's going to be wrong and everyone's going to be sad. What's the next one? Is that 11?
Yes.
All right.
I don't know.
1 0 1 1.
That's an
1
and.
0 1 1.
And.
I put the dot. See that dot?
No, we don't see that dot.
You don't see the dot. Everybody else can see the dot, Kate.
See the dot? You can't see it over here. You can see it over there.
Yeah.
Yeah.
So, not A.
Now we
bam.
can see it.
A dot.
Or
B.
D.
Or.
Or not D.
Alright,
Do we
14.
have another one?
14.
1 1 1
The
0.
military weapon.
1 1 1 0.
Woo!
All right. What is it?
A naught.
or B naught or C naught or D. Whoa, we're getting crazy in here.
All right.
Party.
Any questions?
Not yet.
Not yet.
No, not yet.
All right. Any Boolean function can be expressed as a sum of min-terms. Okay? You can always convert it to a sum of min-terms. This should be at least somewhat intuitive, because if it's complicated like this, you just keep distributing it out until you have the sum of min-terms. Okay? All right. And this is probably going to be the easier way to do it, because you start with that. Sum of min-terms equals m sub 3, m sub, right. So if we started with this function, distribute it out, x, y, well, as a min-term, that's 3, m3, little m3, x naught or y naught, m2, and then of course x naught, y naught, m sub 0. All right. So now, the other question is, what if you don't have all your variables together, like a or b naught c? There's 3 variables, but we don't have them in standard form. We can expand. We can expand. We're just not going to tell you how to do it.
All right.
That's all right. Cool. All right. How do we do this? Well,
First write down the equation.
1 and I don't know why I did that. 1 and a. That's just a, right?
Yes.
Or 1 and b naught c. 1. That's still bc, right? Right. All right. So the first one, we're going to convert 1 to be b or b naught. The second one we'll convert it to c or c naught, and then we'll have a over here. That way we'll get the b and the c terms in there, and then over here we need to do the same thing, but with a to get the a terms in there. And then we multiply it all out.
Yeah.
I wish I didn't do that. Okay.
I wish you didn't do that.
So the first one is A, B, C. Maybe I see why that wasn't part of the slides. And then, woo, next we'll put what? A, B, not C? Sure. And then we'll
You
do
did not B.
A, what's that?
You did A, not B, C. Did you want to do A, B, not C?
That's A, B naught.
Oh, A, B. Yeah, I seem to say it the other way that y'all do. I'm trying to pick it up your way, but is that the way you were taught? Put the not before it, so A, not
I don't
B?
know. That's just how I saw it.
I said B.
It doesn't really matter.
I
as
said
long
it
as
after.
you write it down right.
Okay, good. As long as I write it down right. Thank you. We'll see if I can keep that up. A, B, what is it, C naught? Now I'm just A, which one am I missing?
ABC.
Yeah,
B
B.
naught, C naught. There we go. Woo. Plus, okay, this one's going to be easier. A, B naught, C, or A naught, B naught, C. All right. And now you look at it and you say, do we have any things that are the same?
Yes.
Which ones?
A, B, not C.
Where's the second? Let's see. Oh, yeah, here we go. So we only need one of these. Good. All right. What's the min terms?
Whatever those things are.
Well, if they're not complemented, that tells you the number. So it's 1, 1, 1, which is 4 plus 2 plus 1 is 7. So we have a little m7. We have 1, 1, 0.
6.
We're going to look at the next slide and see if we did this right. This one you have 1, 0, 0, which is
4.
and this one is what? 1, 0, 1.
5.
5. Oh. Whatever. And then 0, 0, 1, which is. Alright, I wonder if I did this right.
Sure.
Hey, I did!
Oh, that looks like a mess.
Which What's your M5
You should,
doing?
My
no,
M5
don't
what?
erase it.
What's your
Don't erase it.
M5 doing?
Don't erase it. Go back, online students.
What about them?
They need to see that.
No, they don't. Thank you, Caitlin.
Yeah, it's gonna help us later too.
Super professional.
Hey, at least you didn't turn it on. Just,
Wait, I'm going through the
what
slides.
are you doing?
Why are you moving through this?
Because the apparently my keyboard is broken. Uh oh. There. Nope. Because I'm putting in the keys to change the workspace. There we go.
Oh gosh.
Look what you
That
did.
looks terrible.
Deception.
We had A. Oh, this is great.
Probably just take the camera and just run.
Where? Oh, oh.
Yes.
There you go.
Oh,
It's so much worse. It looks like we're in a 90s music video.
Worth it.
You're
Jonah
welcome,
broke West.
I'm sorry, online students. We have 1 and A or 1 and B not C. You expand the first one to be B or not B, the second one to be C or not C, and then you put A. The next one you put it to, oh, good luck, people, to A or not A, and then multiply it by not B,
If
C.
you just look at the middle one, it's not too bad.
And then you distribute the A out, so then you get all these terms for A, and then you distribute the BC out, you get those terms, and then we determine, oh, hey, look, that BC and that A, I'm sorry, that term, which is A, B not C, is the same as this one, A, B not C. We only need one of them, so cancel that out. Now we need to convert it to the sum of midterms. Well, A, B, C, if it's not complemented, that's a 1, so this means 1, 1, 1, which is 7. So that's a 7 right there. Again, 1, 1, 0, because the C is complement, so at the 0, that's 6, so that's that guy right there. 1, 0, 0, A is not complement, but B and C are, so that is 4 right there. Over here we have A, 1 for A, 0 for the B not, and then 1 for the C. That goes to 5 right there. And then lastly, A not, B not, C is 0, 0, 1, or aka 1, so there's your midterm right there, and I'll go ahead and put a plus.
Yeah.
Yeah.
Then I can go back.
All right. Thank you.
Then I can erase that.
Well, I'm going to.
That was a headache. Why'd you have to make him do that?
Someone's going to
So we can
appreciate
look at it
that.
later.
All right. So we've converted it to the sum of min terms. Notice how this was a standard variables in order to drop the m designators. Okay, so in other words, we just use this little summation, little m, and then put in the numbers. Okay? Simplifying it even more, or at least how we write it. All right. So that's the min terms. We can also do the product of max terms, which is the same thing, except for now you need to make everything a product of ORing, which can be done. Hopefully this is intuitive, because I just showed that you can always go to a sum of min terms. If you complement that, then you can always convert it to a product of max terms. So, oh good, they wrote it out, because I didn't want to do this one. X, Y, Z, X or Y, Z. Well here, what do they decide to
If
do?
it just says X or not.
X or X not, Y not.
Oh,
They
okay.
just distributed it.
C's just gone.
Yeah, so they distribute it, and you keep doing the distribute rules until you finally get what you need. I'm not going to ask you to do the product of max terms. I'm really going to do the sum of midterms. Yes, because this gets complicated fast. Well, if I do, let's see if they help you.
Give us the answer.
Oh my goodness. Convert product of max terms. So we have this, which is the min terms. Oh boy. And then we multiply it out. All right, there. I'm just going to say we do
Why
math.
is the z equals b higher than the 2 get?
You know, I don't know. All right, function complements. Let's make our lives easier, because it actually is a lot easier. The reason I did this is I'm going to say, hey, look, it's complemented. But if you just complement it, you're actually fine. Hey, look, if x, y, and z, the midterms is 1, 3, 5, 7, then the complement of that is midterm 0, 2, 4, 6, which is just the max terms. In other words, this guy up here, this is kind of written weird. So once you have the sum of midterms, you can quickly convert to the product of max terms. Yes.
Okay, so
Don't look at this, because these are the complements.
okay, so ignore those.
Ignore this for now. But the point is that, remember, the max terms is the complement of the min terms. Remember that proof? So if you're going to complement it twice, which I said is very nice. That rhyme. Okay. Very nice. Then you really just flip the numbers. AKA you fill in the numbers that are missing. And now you have the product of max terms.
Oh.
Oh, yeah, you see that?
What if there were a lot of numbers missing?
Right, so if there was
Like-
1, 2, 3, 4, 5, 6, 7, then the product of max would literally be just 0.
Oh. What if it was like 1, 7?
Then you'd have to
Then
do
I just
0,
need
2,
everything
3,
else.
4, 5, 6.
Oh,
You literally just put in the ones that are missing.
okay. And we stop at whatever number it stops at.
All right, so to convert between them, find the function complement by swapping the terms, change from the product of sums, or vice versa. So notice that it's 1, 2, right, which gives us, if we complement it, you just get the other numbers. So therefore, we then change by De Morgan's law to the product of net, right, to form the complement again, giving the other form of the original function. So in other words, if you need to get the product of max terms, so when I said you didn't have to do the product of max terms, I was really saying you don't have to do it the hard way. Just find the sum of min terms and then convert that to the product of max terms. Okay. So yeah, equations are written as OR of ands is the sum of products. The product of sums is written as an and of ORs. Okay. They wanted to make sure you noted that, hey look, my power's running low.
Oh no. Turn off.
They wanted to make sure you understand that, again, the way it's written is very strict. It has to be in the form of the product of sums or the sum of products, which is this one, or the products of sum, which is the second one. If you try and mix it, it's not acceptable. It's not a thing. There, now I'm charging. In other words, it's not in standard form. These two down here are not in standard form. This one because you don't have all, this one's not, because you got to distribute it out. And then neither is this one. Notice that it's not a simple sum of products or a product of sums. You have a sum with the product inside of it. You have a sum of products that are then being multiplied again. So this is not standard form. This one, that term's okay, but in here you have a product of a sum, and then you have multiplying it again. So again, that doesn't work. Okay. A sum of min-terms formed for n variables can be written down directly from a truth table. Yep. So the compiler could just quickly compute the truth table as your sum of min-terms or product of max terms and then try and figure out the final circuit from there. For example, oh, perfect. So if you do the calculations, this is your min-term. How can we simplify this? Anyone? We're almost done. Rearrange stuff. I like that. Let me take my cheat sheet out.
good stuff on there?
Oh yeah.
All,
Right.
all the answers to life. This is a giant 42.
Why is that the answer? Like,
All right, guys. Let me write the first term. A naught, B naught, C. Can you take an A out of all that?
Yep.
yes.
All right, let's do that. What is this?
Oh, it's
It would be a 1.
It'd be a 1. Why is that a 1?
Because at least one of them would be a 1.
Yeah, one of them has to be a 1 because it's really all the possible combinations of these guys. All right. So now you have A naught, B naught, C, or A.
Pull out the A.
Woo!
None of the A's one, so man.
Oh, yeah. It's
Yeah, A has
Well,
to be
it is.
either.
Yeah.
Well,
No.
No, that's a
No.
lie. I don't know.
no, because then it would just wait.
JK.
No, this is the thing that we did earlier.
Yes.
Yeah, so it's just A naught, B naught, C
Well, yeah, this actually turns into
because
B naught, C,
B naught,
or A.
right? Because
What, you don't remember? All right, let's go
Right.
back.
that one. That was
It's that 1.
yeah.
Long
It's that one.
It was a long, long time ago.
Earlier.
Whoops.
And it
Whoa,
goes
whoa,
too
it keeps
far,
going.
far away.
Whoa,
Whoa!
whoa, whoa.
You broke it.
No, it's not that one.
No, JK.
There we go. Hey, look. It's...
That one.
Where is it?
JK.
Wow. Isn't it? It's gotta be this one? Oh, wait.
No.
It's one of these two.
Yeah, it was the one you pointed at.
Yeah.
Yeah. Because...
X
Yeah.
or not X and Y.
Right. And
Makes
then
X
this is
or
Y.
Y.
Right. So then that just
Right.
means it's...
X or Y.
So by the simplification... That's actually an arrow, not a happy face or something else.
I like the fact that it's a happy face more.
Doing the time warp. All right.
I feel like that's a dance now.
Have you not seen the movie?
Don't watch the movie.
Yeah.
Don't watch the movie.
Wait. What movie?
I've never
Don't watch
seen
the
it,
movie.
but I've heard things.
Don't watch the movie.
Just
And
don't.
go to the show.
Very
But the time warp is amusing. That's like the only good thing for the whole movie.
My
much the
mom
only
loves
thing.
that movie.
I'm so
She said
Anyways,
it's fun because the
So, how many
interactive.
literals were up here?
Yeah.
Well, there are 15 of them, and we just simplified them to 3. Right? So, in other words, the beginning circuit looks something like that on the left, and the
Gross.
final circuit looked like something on the right.
Gross.
Wait a minute.
Hey,
See,
that
have you
looks like
seen?
something
Wait a
we
minute.
coded.
Hold on a second. Hold on a second.
Hold up.
Wait a minute. Hold on.
That was our lab.
What did I just do to y'all?
Give us a simplified version of our lab.
Yeah. This is your lab. So now you've done your lab 1. Hopefully, when you do your first circuit and you do your second circuit, your output should be the same.
Oh. I need to go check that.
All right. And why is that? Because of math.
Because of brain.
Because of math. All right. So we've gone through a lot of math to come up with a complicated way to prove that these two are equal.
Wow.
Woo.
That's just a truth table.
Just going to truth table. Well, the computer can't really, truth table. What is it going to do? Guess the second one's correct?
Yeah.
Yeah. Well, it can't. How is it going to go? How would it know to come up with this on the right from what this is on the left?
Magic.
Magic, right? It doesn't have magic.
It does.
We
Doesn't
do,
matter.
but not computers. So
I believe that everybody has magic.
so we have to come up with how can we actually have a computer migrate from one circuit to another. And we're going to go into that next time. But before I conclude, let's see. Previous show, canonical forms. So the question is, how can we attain the simplest expression? Yes, how can we obtain the simplest expression? Because obviously the one on the left is not what you want in your processor design, especially if the one on the right is possible. So how can we go from the left to the right?
Simplification.
Simplification.
There you go.
All right. Is there only one minimum cost circuit?
Yes.
That's it. Is there only one minimum cost circuit?
Probably not.
Probably not. So there might be more than one minimum cost circuit. Hey, look, the next part we're going to deal with these issues.
Next time.
Next time. The end.
Oh, yay.
Any questions? I know this is weird because it's like we just talked about a bunch of stuff and don't know why it's used.
Our picture show.
On that slide, on that slide,
Yes.
the one about that showed the gates and such. In our lab, is the top one not A naught on the left?
No,
It
that's
is.
just A. It's A, B, not C.
Oh, it is A naught.
In the lab, it's
In the lab, it's A
Oh.
naught.
Stop. It's A naught here as well. See, it's A naught, B naught, C. Oh, they didn't appear. Does that help?
Yeah.
Better.
No.
Everything has been destroyed.
Everything is lost.
Oh, okay.
Well, I think it shows
Oh, yeah.
up as A naught in the lab.
Don't worry about the slide,
description
you probably fixed it.
picture. I don't know. Maybe.
Good question. Any other questions? Comments?
I was
I
just,
just
was looking
need
at it, I was like,
to
that should be like, I know I wrote something different. Abby.
Nope. Nothing. All right. Well, that is all for today. We will have homework over this next time,
sweet.
Oh no.
as well as K-maps. All right. Well, have a good weekend. I will.